In this section, we will see how to find out the first and second order derivative of an image and how this first order and second order derivative can be used for detecting the point, line and edges in an image. So for that we consider the image shown here. Just consider the image shown. So here you have an image and I just take a intensity, horizontal intensity profile through the center of the image. So I consider a line through the center of the image. So you can see and now the intensity is going to decrease. So you have an edge like this and at this point you are having a point. So at the point you will be having a certain rise in the intensity. Then there is a line at this point. So there is an edge like this. Then after that there is a sudden change in the intensity, that is you are having a step edge. So this represents a step edge. So in this image I am having all the intensity variations like point, line and edges. So that same thing I just represented like this, that the same thing I just represented it by the intensity as one of my axis and the ramp edge. I just represent the intensity, that is 5, 4, 3, 2, 1. Then that point I represented by this point is having the intensity at 6 and then the line, this is the line, then the step. So I just mark the intensity levels. Okay. Now this is my image strip and these are the intensity levels in my image strip. So this actually represents the intensity levels in my image strips. That is whatever the value I have here, I just return it as an image strip. Okay. So you have 5, 4, 3, 2, 1, then again to 0. Then at region you have a sudden increase to 6 at the when you have a point. Then again 0, then you have the line, that is 1, then an increase to 3, then again to 1, then again to 0. Okay, so this represents the intensity profile, that is the image strip. Now in order to find out the first order derivative at this point, if I want to find out the first order derivative at this point, what I have to do is, my expression is, here I have the expression for first order derivative is fx plus 1 minus fx, that is the first order derivative at point x. Okay, fx plus 1 minus fx, that is, it is the point x. So fx plus 1 is 4 minus 5. So you have 4 minus 5, 4 minus 5 is minus 1. Similarly at this point it will be 3 minus 4. So 3 minus 4 is again minus 1. Similarly at this point, when you consider this point, it will be 2 minus 3. 2 minus 3 is minus 1. Consider any arbitrary point. Consider this point. I have to find out the first order derivative at this point. So first order derivative at this point means fx plus 1, that is 0 minus 6. So my value will be minus 6. So that is how I find out the first order derivative. Okay. Similarly, to find out the second order derivative, this is the second order derivative is given as fx plus 1 plus fx minus 1 minus 2 times fx. So if I consider a particular point, just say if I want to consider a particular point, then if you consider one particular point, I want to find out the second order derivative at this point. So consider this point. So I want to find out the second order derivative at this point x. So second order derivative is given by fx plus 1 plus fx minus 1 minus 2 times fx. So this is my fx plus 1. So 4 plus fx minus 1, that is 4 plus 5, that is 9 minus 2 times fx. Okay. So 9 minus 2 times 5, 32 times 5 means 10. So 9 minus 10. So my answer is minus 1. Okay. Similarly, if I want to find out the second order derivative at this point, I will be having 0 plus 1. 1 minus 2 times 0. So it will be 1 minus 0. So my answer will be 1. Similarly, if I want to find out the second order derivative at this point, that will be 1 plus 1, that is 2. 2 minus 2 times 3, that is 2 minus 6. So my answer will be minus 4. Similarly, if I want to find out the second order derivative at this point, 7 plus 7, okay, that is 14. 14 minus 2 into 7. So you have 14 minus 14, that is again 0. So this is how we will find the second order derivative. So here we have all the first order derivative and the second order derivative. Now see how this first order and the second order derivative can be used to detect the point, line and edges. So you just compare this figure, just go through this figure. So you can see here I am having a ramp. Okay, so when you take the first order derivative, you can see at the onset of the ramp and along the ramp you are having a non-zero value. Okay, then you consider the second order derivative, you can see at the onset of the ramp you are having a non-zero value. Similarly, at the end of the ramp you are having a non-zero value. So through the ramp the value will be 0. Now consider the case of an isolated point. So if I have a point in my image, my first order derivative, you can see my first order derivative is having the value minus 6 at the point, and the second order derivative is having a higher value, that is minus 12. So if I am taking in order to detect my point, I can either take the first order derivative or the second order derivative. But second order derivative is having a larger value, or by using the second order derivative you can detect the isolated point. Okay, so because it is having a very larger value, that is minus 12 compared to minus 6. Now consider this line. Line also, here I am having a value minus 2, here I am having a value minus 4. Similarly, if I consider the case of a step, you can see when you have a step like this, the first order derivative you are having a value 7, then 0 along the step. But when you consider the case of a second order derivative, at starting you are having a plus 7, that is there is a sudden increase, then there is a value 2 minus 7, there is a sudden decrease. So the second order derivative having shoot as well as, and there is a the value will also false. Okay, so by examining this first order and the second order derivative, we can find out the presence of a rampart, or presence of a point, or presence of a line, or presence of a step. Okay, so this property is used for the detection of the point, line and the edge detection. So what you have to know is just how to find the first order derivative, that is just by using this expression, and how to find out the second order derivative. So by using this first order and derivative, you can find out the presence of the point, line and edges in the image. Okay, so that is all about this session.